Hi, this is Mr. Zachary, and this is question 18. This is the bungee jumper. The first question, it says that the bungee jumper has a mass of, has a weight of a certain amount. And first thing to do that you need to do is to find out the mass of the bungee jumper. Turns out the weight is 700, so you can say weight is m times g. So you find out that the weight of the bungee jumper is 70 kilograms. Now at point A, it's kind of unclear in the question, but you can assume that the person is not moving yet. The bungee cord is not stretched, so they won't have elastic potential energy. So all of the energy will be gravitational potential energy. But how much? Well, we know that the gravitational potential energy at A is mgh at A, height at A. So we know that the height is 50 if we make the ground a height 0. And so we get a gravitational potential energy of, this should have been 35,000 joules. So putting that in, 35,000 again should be here. And if I know that the total at A is 35,000, there's nothing interfering, then I know the total at B and the total at C should be 35,000 also. So the next question asks how fast is the person moving? Well, I can say that there is no elastic yet at B because it says that a person falls 20 meters and the just then is where the bungee cord gets tight. It hasn't started to stretch yet. It is moving and it does have gravitational potential energy because it's above where we've made height 0. We do know that the total must be 35,000 because the total at A is total at B, total at C, even if I forgot to add a 0 here. So if I look at that, I can say that the gravitational potential energy at point B is how high it is up, which is 30 meters. It fell 20 meters. It's 30 meters off the ground. So the gravitational potential energy is 21,000. Well, we know that the total is 35,000. So how much kinetic energy must there be? Must be 14,000 joules of kinetic energy. The total is 35 minus 21, which is the gravitational, gives us the kinetic. And then how fast is the person moving? Well, we know that kinetic energy is 1/2 mv squared at B. Plugging in the numbers that we know, and we can find that at B it must be going 20 meters per second. C asks, how much does the bungee cord stretch by the time it gets to C? Well, if it hasn't stretched at B, and that's just where it starts to, and it's stretched all the way down to C, then it must have stretched that whole height, which is 30 meters. And then finally, what is the spring constant of the thing, the bungee cord? Well, we know that the total has to be 35,000 total energy. We know there's no gravitational because it's at the ground now. We know there's no kinetic because they get brought to a stop down here at the bottom. And so all of it must be elastic. So there must be 35,000 joules worth of elastic potential energy at point C. So plugging that in and knowing that it stretched 30 meters, we can find out that the spring constant must be about 77.8, 77.7 newtons per meter is the spring constant for the bungee cord.